Practical SQL Server 2012 Administration Programming Select Statement Recursive Queries and Tree Processing. Let's check out the Bill of Materials table. In the production schema, AdventureWorks 2012. So this is Bill of Materials. And we see that the component ID and the product assembly ID are foreign keys. Actually, foreign keys to product ID. These are all products. But a component ID may be present in product assembly ID as well. So this gives the tree relationship. If we check it out, all these component IDs are also in product assembly ID. So when we do recursive processing, we use, which is a new feature to SQL Server 2005, a recursive CTE, and it has two parts, root node and recursive node. Sometimes this is called anchor as well, and the union all operation is used. And here is the recursion. CTE parts. CTE parts is the definition of this CTE to begin with. So that's the recursive part. And in the recursive node, we have some kind of a stopping. So recursion stopped when this keeps continuing until end date is not null. Let's run this query. Execute. And this is the result. Let's go to the next query. In this query, we are selecting a particle assembly, and that's 801. Execute. Now this is identical in terms of recursive CTE. Execute. Let's just sort it on the assembly first. And component level second. And rerun the query. Actually, let's make a little improvement. Eliminate one line. Save. Execute. Fix. Save. Execute. Now we see for the ball bearing assembly, we need the following components: the ball bearing, cone-shaped race, cup-shaped race, and a lock ring. And that is the assembly for ball bearing. And for the entire product, there are 87 rows in the assembly. And what is this product? Let's check it out. And the product is, it's a bike. It's an entire bike, road bike, yellow. BK is for bike. Let's pick a different part, and this one is different product rubber. It's a front derailleur. FD. Let's run the query. Improve it. And save. Execute. So this is rather simple. There is a cage and the linkage. In the following recursive query, we are back to the employee table, and this is in AdventureWorks. So employee table in AdventureWorks has the manager ID, employee table, and here is a manager ID, a foreign key, which is pointing to the employee ID in the same table. And we do the same kind of recursive processing with recursive CTE. This is the anchor or root, and this is the recursive member. Let's execute it. And here is the result. 109. This is in original AdventureWorks. Ken Sanchez, the CEO. And it goes down to all 290 employees. And the CEO does not have a manager ID, so that's our anchor as null. Manager ID is null. Well, how did we do recursive query before recursive CTA? Actually, we can do it with a while loop. And let's run it in Northwind. And this is the while loop. And finally, we have to assemble the result into a nice form. And this is the result. Here is the manager and here is the employee. This is only the sales department of Northwind Gourmet Distributors. Let's consider a couple of interesting functions not related to recursions. This is table sample. 10% table sample, so 1410 rows. If we do it again, well, we don't get exactly the same. It's 1200, 2200. This is a sample of sales.customer table. And this is a repeatable sample. Aggregate functions with table sample. So we just calculate it on 2%. Or we want the average instead of calculating on the entire table. This is good for testing. In production, you don't want to do that. You certainly don't want to give your management sampled values for average order quantity. You want to give real values. These are set operators. Intersect, except SQL Server and any RDBMS engine works with unordered sets. Save. Let's create tables for the testing. So we deleted 10% and we do an intersect, and this is the common part, and because we did the deletion, it's not the entire table. We can also get it with an inner join, the intersect part. Same number. Intersect is same as join on all columns. Select star from sales customers except. So this is the opposite operation. It's 1982. So that's the set we deleted. And this is an alternate operation with the same results. Drop the temporary table. Recapping, recursive processing is really easy with recursive CTEs. This is a very powerful feature of SQL Server for sophisticated operations where there is a tree structure in the data. We can use the recursive CTE facility to process the data. This is the end of the unit.